I'm now ready for part 2 of our two-sample proportion hypothesis test. That's a mouthful. Where we left off, we had our null hypothesis was that the two proportions are equal, and our alternate hypothesis was that they weren't equal. And again, you're welcome to write these two as your null and your alternate, or what's going to happen in StatCrunch is they're going to move it to the other side because it's that idea of capturing 0 or not capturing 0. Okay. Our measuring stick, our significance level is still 5%. And just as we saw with the one sample test, I'm going to be going to StatCrunch to use a z-stat and a p-value. So let's go ahead and kick this off. So what I'm interested in is basically how unusual is it? So is this a really small number? If it's a really small number, it's very far in the tail. So that would mean it's less than 5%. And if that were true, we would reject the null, meaning that they are different. If it's not a really small number, if it's not in the tail, it's saying that the two values are actually really close to each other. So if that's the case, we would keep or fail to reject the null. We'd say that those 2% are in fact statistically close enough to be considered the same. All right, so let's go ahead and go over to StatCrunch. So over here, I go to Stats, Proportion Stats, two sample with summary. All right. My first value I'm going to plug in is the 75 out of 112. And the next one was 63 out of 104. All right, awesome. Now I'm going to go ahead and make sure that my hypothesis test is checked. And as you can see, it says P1 minus P2 equals 0. So you don't want to change it. That's exactly how we want it. And we're just going to use the default of does not equal to. If I want to change it to less than or greater than, I could if that was my alternate. But my alternate is does not equal. I hit compute. And there we go. My z-stat is 0.9765 or 0.977. My p-value is 0.3288. All right, something interesting happened. What happened is that this is saying it's not in the tail. It's in the big middle hump. So what that means is that we are greater than 5%. These two proportions are actually close enough to be considered the same. We would keep or fail to reject the null. What we're saying is that this is still true, that P1 is in fact equal to P2 statistically speaking. So our conclusion would be, according to our data, the 2% or two proportions are statistically the same. So even though we had 67% and 61%, which look different, technically those are still close enough to be considered the same. Now remember, a hypothesis test is making the statistical argument for us. So by finding the z-stat, by finding this p-value, we're showing it's not unusual, so this is true. If it were in the tail, I'd say it was strange, we reject the null, but that's not what happened here. All right, part 3, I'm going to show you what happens when we do a confidence interval.